Well, welcome back to Modeling Time with me, Brian Banna. So let's get a quick recap of what I've gotten done so far. I've gotten the frames done, and I've got the trucks done and installed on the frames. So it's time to move on to the next step. And the next step is to get the motor in, the soundboard, the speakers, and stuff like that. So there's something I need to show you real quick with the motors, and then I'll give you a recap. Actually, what I'll do is I'll go over what I'm going to do, and then I got to show you something with the motors. Just a little heads up on them, on these KATO motors, something to pay attention to. But real quick, let me show you this down here. My yard is pretty much filled up. I have a room for about 3 or 4 more cars, depending on the length of the cars, and that would be at the very end, right back here. There's a room for about 3 more cars. But realistically, I think my yard's pretty much filled up. These are the most recent cars I just finished. These piggyback trailers, or flat cars, and the trailers on top of them. So anyway, let me get the camera set up, and I'll go over a few things that's going to be done, or what is going to be done in this video, and the little heads up on the motors. Alright, so I got the camera set up over here. Now this motor, I've already done work to it that I'm going to show you on these 2 motors, but I'm going to use this one to explain what's going to go on in this video session. I'm going to be using the Lokesound V4 direct select boards. This is a junk board that I use for testing stuff and making sure things fit, so I'll just use this for an explanation. Right now I've got a tool coming in because I need to cut these posts down. And the reason I need to cut those posts down, I need to make it so that this board, or actually this board that I've had made, there's 6 of them here, this will sit on top of here. Let me zoom in a little bit. Alright, so just pretend that this is in the frame. This sits up a little, this post puts the board up just a little too high. So I cut this down so that this bracket will sit 20 thousandths off the top of this motor. And I've been doing that just by eye with in the past, but what I did is I made a tool that has this shape, this post shape in it. It'll fit over the posts, and it's thick. It has this curvature in the top of the motor, and it has 2 wings that come down the side, so it fits snug around the motor and over these posts. Then as it sits on top of the motor, then I can just shave these posts off with the razor blade, and it'll put this bracket 20 thousandths above the motor. So that way I can just screw this motor, or this bracket, right to the motor. I have the shape of the posts on the other side of the bracket as well. So then that'll sit over the motor, and then I can put these decoders onto the standoffs. I can thread the holes in these standoffs, and from there I can put a screw in to hold this tight. Now for speakers, I have a whole bunch of these, so I was figuring why not just use them up. I'll be using 2 iPhone 4S speakers per locomotive, so that means I need 12 speakers, which I have there. So what I've done in the past, and it works out really well, and to me it sounds really, really well also. But what I do is the speakers will be the same length, and I'll cut them in half and then glue them back together, and then what I do is I glue them to the bottom of the board so it all fits in between these posts. And I'll be going over all of that, so you don't have to sit there and think, well, how is he going to do that? How does that work? And I'll show you how it works. So that'll be done. And once that's done, then I can mount these here, and the speaker wires will come up and go to the speaker pads and such. So that takes care of that. So now you get an idea of, you know, what's going on. The keep alive goes into the weight on the end of the back of the frame. And when I showed you the frame and how I was doing the frame and everything, I think I showed you the where I used the ball end mill and cut out the area for the keep alive. So what I'm going to get to first here is getting these wires up the motor, and that's what these holes in these brackets are for, is for the wires to come up the side of the motor through these holes and then right into where they go for the decoder. But before I get to that, I want to show you something to keep in mind when you're working with KATO motors. A while back I had sent an email to KATO asking how do I know what side of the motor is negative and what side is positive. And I didn't know at the time. He wrote back and says, well, there's an N cast into the end of the motor housing to denote what side is negative. And so I looked there and I was like, oh yeah, there is. There's an N right there. I don't know if you can see that N in there, but that's the negative side, and that's the top of the motor. Now what denotes the top of the motor? Not necessarily where I wrote top on it, of course, but this white dot. And doing these 6 motors, I just found something that was just a little bit interesting. So 4 of these motors have the N at the top of the motor. 2 of them have the N at the bottom of the motor. I don't know if you can see that N right there. And that was puzzling to me, but it turns out that what had happened is they just put that casing on upside down. So the N should be at the top. So if I were to, let me pull these forward here. So I've got this battery here. So we got the negative side. So you know what the top and the bottom of the motor is because the long lead goes to the bottom of the motor and the short lead is on the top. So this motor has the N at the top of the casing. This one has the N at the bottom of the casing. So if I take the negative on the battery and I touch the negative to negative, the motor spins in a clockwise direction. Now if I touch the negative from the battery to the negative, what it says is the negative lead on the motor, the motor spins in a counterclockwise direction. So that tells me that even though the N is on the bottom of the motor casing, the negative is still at the top. So if I turn this around and just touch it to the leads, it spins in a clockwise direction. So just to keep in mind that the negative is always at the top of these KATO motors, where the dot is. This is the one that has the N at the bottom, but you see the dot is still up at the top, where this is the one that has the N at the top of the motor and the dot is at the top. So that's just a little tidbit or a little, keep this in mind when you're wiring up your motors, because I'm going to be putting a red wire to the negative and a black wire to the positive. So now let's get to what this is the start of this video. Well, actually the video started, but let me get to the start of the workload of this video. So because I'm going to be putting the board on top, I want wires coming off of these leads. Let me put this one aside. So we know what the top is. I always write top, and I always put which way is forward, which is the front of the motor. That way I don't have to always be putting it in the frame to figure out which is which, and you know, I don't pay a lot of attention sometimes to what I'm doing, and I'm likely to solder the wires to the wrong side and stuff like that. So the first thing you want to do, or the first thing I will do, you don't have to do this, this isn't necessary. I do it to keep everything tidy and stuff. I'm going to zoom back out here so I can work on this and be in camera. So on the top lead, since on the DCC board, the motor connections are on the left side of the motor. So if this is the front, this is the left side. So the holes in the boards, where's my boards? There we go. So the holes in the boards are on the left side. So I want all my wires coming up the left side. You'll notice that the bottom lead comes up on the right side, so we're going to have to turn that one around. So the first thing I'm going to do is I'm going to cut this. I'm not going to cut it all the way off. I'm going to cut it off enough so that I can solder a wire to it. I got my Xeron photo etch nippers. There we go. You want to try to keep from pulling these bushing keepers out. They're in there pretty tight, but once you pull them out, they never seem to stay in the same. So that one's cut. And now what we want to do is we want to rotate this one to the other side. You don't want to cut this first, because as soon as you cut that, this portion becomes very stiff down here. So I just kind of lift and rotate. Keeping that keeping this brush holder down, and then I just press it back down over the motor and come in and I cut it just long enough so I can put a solder lead on it, or a solder a wire on. So that takes care of that. So now we have the top one cut and I have the bottom one cut. Now what I want to do, one of the reasons I do that is because with this lead, I want to keep the wire inside the motor area. And to do that, what I do is there's a cavity right here and a cavity here. The wire is 30 thousandths diameter, so there's plenty of room to drill a hole through here, here, and here, and pass the wire up through the motor, the plastic part of the motor casing. So I just mark a spot. I got myself like a 42 thousandths. Any size drill bit is fine, just as long as it's larger than the diameter of the wire, and maybe no larger than about 45 thousandths, 46 thousandths. So what I'm going to do is I'm going to drill perpendicular into the circular part, and once I get into a little bit, I'm going to start rotating the drill bit to start going vertical. Like that. So now it's in a vertical position, and now I'm just going to start drilling it all the way through. So there you see it going through. Let me zoom in just a little bit here. There we go. There you see it's going through. Now I'm going to spin it some so it digs a little trench. Hopefully you can see that. There we go. And then I'm going to go through this middle section. You want to try to keep your drill bit from flexing too much. There we went through the middle section, and now the drill bit's kind of angled out, so if I try to drill through this, it's going to come out the side. So I want to pull that out. Sometimes I can get it to go straight all the way through, and then I'll just do it from the other side. I'll just drill it from the other side. And there we go. And then I'll just come in with a knife and just cut off any slough from the drilling. It doesn't have to be pretty, it just has to hold your wires. Right now I'm just cutting the, there we go. So now I can solder the wire on the bottom, pass it through these holes I made, and it'll just come out the top and it'll be held nice and tight, so when you put your shell on, that's not interfering at all with anything. So then the wires will just come out the top. The problem I had with these copper strips was they would flop out a little bit, and when you go to put your shell on, the shell would go inside of it, and then you go, oh crap, I gotta take the shell up and adjust it and all that. This way everything is kept nice and tidy right inside the motor, and then everything will come across the top and right up into the DCC board. So the next step is to solder wires on. But let me go ahead and get this one drilled out, get all my soldering gear out, and we'll go and solder everything. This is the last one I have to do. I've got all the other motors drilled out and stuff. So let me just go ahead and get this one done, and we'll get it all soldered. Okay, so it's time to solder the wires to the motor. For the red wires, I cut them 1.5 inches long because they're only going basically from here a little bit down the motor and then right up to the board. So these are 1.5 inches long. They'll be plenty long to get to the DCC board. So the first thing we do, I don't cut the black ones yet, and I'll show you why. So the first thing I do is I tin the ends. Put some flux on there. Get some solder on here. Do the other end. There we go. Now we'll solder it onto the motor. So I can put the solder off to the side. I have a Weller soldering station. Oh, sorry. That thing right there. Can't get the tips for it anymore, but I had bought plenty of tips, so I have enough to last me a while before I have to buy a new station. Okay, so now we want to solder the red wire to the top. There we go. So I'm going to flux it again, put some goo on there. Put a little goo on the copper pad. Put some solder on the iron. And we're just going to hold that in place. Oh, it's just a little long. Need to cut the tip off a little bit. There we go. Get some new solder on there, clean that off. I need a new sponge. Okay. And that's on. Now, the reason I don't cut the black one yet is because I want to make it the same length as this red one. So let me open that up, get the black wire out, put it down through the hole. Like that. There we go. Now I'll tin the end of that. Put some goo on there. Some solder. Alright, now I gotta solder it to the bottom. Bend this at a 90. Okay, so I'm going to hold it over there with my finger. It's going to get hot, but I think I can get the solder on there fast enough so that I don't burn my finger. Let me get some goo on there. The magic stuff. Get some solder on there. And that's it. No burning the finger. Alright, now I can flip this back over. There we go. And now I will cut it to be as long as the red wire. And then we just have to tin the end. I gotta clean these tools with lacquer thinner to get all of the flux off of them. And that's it. So now I have 6 motors ready to go into the models, except I'm waiting for that tool so I can trim these off. Once I get these posts trimmed down, then I can install the motor into the frame, put the drive shafts in, and get all the rest of the electronics taken care of. So that's going to be probably about maybe a week, because I just designed it. I think it was yesterday or the day before yesterday. Sent it in. It's being printed now, and then it'll be sent to me. So as soon as it comes in, I'll show you what the tool is. We'll get those trimmed off and get the soundboards put in. All right. So in the last video clip, I got the wires soldered onto the motors, or the motor leads for the positive and negative, and I explained all that, and I'm not going to go over all that right now because it's fresh from the last clip. But what you don't know is I had to wait 2 weeks to start this next clip. You might have been thinking, oh, he's just not working on it, and he's working on something else, which is true. I was working on other things, but I was waiting for this tool to come in so that I could continue on. And I'll explain what this tool is in a moment, and such. So I had to design it and get it 3D printed and wait for it to come back. But in the meantime, I was working on other things. Now remember, I think early on in this video, or in one of the videos, I showed you that my freight yard was full of cars. Well, as you can see, it's empty right now. And if you'll notice from the beginning of this video till now, if you look up in the back corner, you'll see a bunch of, let's see, where is it at? There it is. Those boxes up there, a bunch of AccuRail boxes. All those freight cars are now in those AccuRail boxes. And the reason I chose AccuRail boxes, I just needed to standardize on something. These manufacturers use all different size boxes, and it's hard to get your freight cars or your models organized in a nice, orderly fashion when you got different length boxes all over the place. AccuRail offers 2 size boxes. The majority of the boxes I have up there are the smaller size, which fits anything up to a 50-foot freight car. And I have 3 of the larger boxes that'll fit like auto racks and stuff like that in, that I put the 65-foot tank cars in. So all those boxes up there are now labeled, and they have all my freight cars in it. So now I can fill up the freight yard again with more stuff. As you can see over here, up here, let me see. See all those are boxes, freight cars I need to still build. And look at all the different size boxes, for crying out loud. I mean, how can you keep stuff organized like that? So I like the AccuRail boxes. The price isn't too bad on them, so I just buy a bunch of them, and that's where I put all my stuff in. That way it's easy to keep it all in an orderly fashion. So another thing that I was working on, I don't know if anybody of you remember, I had an old railroad that I called the Copper State Railway. Well, a friend of mine, Matt Martin, he's modeling it in the modern era, and helped me to put together a scenario, which I really like, to bring it back to my era. In my era, I had originally also had it as only a leasing, freight car leasing company, and he put together a scenario where it graduated into a full-fledged railroad in the early or late 60s, early 70s. But for my era, for the leasing era, I have 5 of these ready to be finished. So I've got all the decal work done on them and stuff, and I really like this car. It's my favorite grain car of all of them, the ACF 3-bay. So I said, you know what? I've got these decals, the logo from when I was doing locomotives for the modern era, and I put together the scheme for the late 60s. These were built in 66. So I have 3 build dates on them. There's 366, 766, and 1066 for these cars. So I got 5 of these cars done. All I have to do is grit blast the truck frames, get those painted black, and then grit blast the wheels, get those painted brown, weather the wheel faces, get the KATO couplers set up, grit blast them, paint them, and weather them, and then just put everything together. Oh, and I have to put a clear coat to protect the decals, and then I'll do a satin varnish over all of these, and then just put them together. So I got that done, and other than that, I've just been cleaning my shop and getting it ready for the moving on with these GP35s. So what we have left to do is it's now time, since I got this tool in, to get the motors secured into the frame, get 6 of these Loc Sound decoders on them, get the Loc Sound Power Packs, 6 of these Power Packs in there, and you see I've got one that I had tested here. These are the, where did I put the boards? I'll show you the boards in a minute. I got to clean them. And I've got to get the speakers cut and built, and then get the dog bones back in to the drives, and like I said, secure the motors into the drive. So that's what we're going to finish up with in this video. And other than that, let me get the camera set up, and I'll show you how this tool works and why I made it. And oh, one other thing I wanted to show you. Now this might look like just a cylindrical rod to you on the camera, but actually what it is if you look at it closely, it's quartered. So it's quartered all the way down. So what it is actually the fuel tank sides for 1,200 gallon fuel tanks for GP7s, for the Atlas GP7. So what I'll do is I'll cut the fuel tanks in, and then I'll cut, you know, whatever I need out of here to length, and then glue them in. So I'll break these in quarters, clean them up and all that, and glue them in, and I'll have the curvature on the side of the tank for the GP7s for 1,200 gallon fuel tanks. I also have the same thing for the 800 gallon fuel tanks. I made a bottom portion for the 800 gallon fuel tanks, which I'm not sure on my CPT and C GP7s if they're going to be 800 or 1,200. I'm thinking 800 because I like that really tight, you know, that really tucked in tank look to them. It kind of gives it kind of an interesting look, but I don't know yet. I have to figure that out. So let me get the camera set up. I'll go over what this tool is. I'll show you the brackets for these decoders, and get that all. We'll get that all installed, and once this is all done, the rest of the model will go together pretty quickly because we're not doing a whole lot to it. So again, let me get the camera set up, and we'll get to this. Okay, so you saw everything about the frame. Don't need to talk about that. You saw how I soldered the wires onto the motor leads, and I explained the end marking on the motor and all that, so don't have to talk about that. These are the brackets I designed for the. Now this is a test board. It doesn't work, so I use it for testing everything, fit of everything. So basically, you see these posts here and here. You'll see that I have a cavity here and here in the shape of those posts. So these two holes here are for the wires from the motor to come up through to go to the board. And if I fit this in here and there, the board is basically will be screwed down to those posts. And I've got the original screws here. Now these posts were originally to hold the stock circuit board that KATO had put in there. Now the reason I have these standoffs is because I'm going to be using two iPhone 4S speakers. I'm going to cut them in half or slightly less than half and glue them back together so that you got one speaker on this side and you got one speaker on this side, and the baffling will still be inside of them. And those, excuse me, those will then glue underneath the board. So you'll have it so it fits between the posts, these posts here, and you'll have it here, and then of course the other one there. So we'll go over that. I'm just explaining how this is all going to work. And then basically the decoder fits on the post, and then I have to drill and thread these holes. See if that comes into focus here. Come on, there we go. So I have to drill and thread these holes, tap those holes, and then I can put some 080 screws in to hold the board in place, and then again that'll fit up top. Now I need to cut these posts down, and I'll show you what that tool does, but real quick. So the board sits there, then what I do is I desolder the keep alive and resolder it in line. You could actually solder it so it's vertical or whatever, But I do that, and that'll go back here. This board was in a different modeling project, so the wires are too short, so I have to just solder some new wires on it. But anyway, the wires will come over, and this will be glued in basically like that. So this is the rear of the locomotive. Then of course the truck wires will come in and solder to the board. But to get back to what I was talking about with this tool, so I need to cut these posts down so I can lower the DCC and soundboard down as close to the motor as possible without touching the motor. So I want it about 20 thousandths above the motor case. So what I do with this tool, allows me to cut the post down. Now I can't put it on this side, so I just rotate these brackets around. So everything's on the bottom. And I slip this over the motor and the brackets. Now I can evenly trim those posts. So put my OptiVisors on so I can see this. So basically with the nice sharp blade, so I can cut myself, I can slip and cut myself. I'll just come across here, and my first cut's not going to be perfect, it's just going to take the bulk of it off. Then I'm going to come across here and just shave it. It's okay if you shave a little of the tool. And that one's cut. Then we'll come over here and we'll shave this one. Just like that. So now my posts are cut evenly across. I can take that off, rotate these back around. And I can take my tool, or my bracket, and there you can see that it, ooh, all I want to do is break the glass, right? Put that back in there. And there you can see that the bracket is just a bit above the motor. So now I've got more clearance to the top of the shell. So we do that. Then we can just take these screws got one in there. Now these brackets have a little recess for the screw to sit into also, to give more clearance to the motor. I mean to the DCC board. And there we go. So now the bracket is in place. So the next thing I need to do is thread these holes. So what I'm going to do, I'm going to stop from here. I'm going to get 5 of them done, and then I'll come back, and the 6th one I'll do all on camera. Starting from trimming the post, threading these holes, and all that stuff. So you get the idea of what's going on, and then of course the last thing we'll do is we will get them installed in the frame and solder the truck wires to the boards, and then get them all programmed, and we'll have a frame that's ready to run. Alright, I'm at the install part of this video, and it's going to be rather long. It's probably going to be about 30 minutes maybe, but I want to show you everything. It takes me about as long to do the install as the local programmer takes to install the sound files on the decoder. So I've got one loading right now. It's about a quarter of the way into it. So I'm on the last one here. I'm going to set the camera up so that I get the whole work area in, and that way you can hopefully see everything. I'm not going to zoom in on stuff. I'll just explain what's going on, but I think you'll be able to see everything. There's nothing really close up that you need to see on this stuff. There's going to be a couple breaks. The break after, or this break when I set the camera up, then another break when I set the camera up at the mill and then set it back up over here. But other than that, it'll just be a solid run of installing these the decoder and the power pack and getting everything done to finish up these 6 installs. So let me get the camera set up and we'll get right to it. Okay, so I'm going to try to do everything right in this area right here. I'm going to apologize ahead of time if I go a little off camera or if my hands get in the way and stuff like that. So I've got the motor needs to be secured into the frame, but before I do that, there's a few things I need to do to get it all set up. I've got a mess here with all the soldering equipment and everything, so let me get some stuff organized here. Alright, so as I showed you before, the first thing that needs to be done is I need to trim these posts down. So we're going to flip this around. Now, if you don't want to see all of this, you can just skip to the end, but I do want to show it all to you so you can see what's going on, what it takes, for me to do this, and, a little bit of entertainment. So here's that tool I showed you earlier. I'm going to slip it over the top here. Oh, there we go. All right. Oh, it's on the other wrong side. That's why. See, I'm already screwing up. So, oh, I see why. This was pushing out. There we go. So it is on the right side. This copper pad was pushing out and wasn't allowing me to push this thing down over everything. There we go. That's how it's supposed to fit. So we got that. I got a nice sharp knife. Now, doing all those other ones, I realize I don't want to try to cut down to the bottom first. So I'll take a cut that'll leave some of the stuff, some of the posts sticking up. Then I can come back and just shave it off easily. There's one side. Do the same thing over here. And there's the other side. Bring this lamp down a little bit more light on there. There we go. So now I can take this off. Put that aside. Don't need it anymore. Spin these around. So we got the top of the motor. Now, before I secure the motor into the frame, I want to take a little bit of this Labelle HL664. It's a gear lube, but it's really thick. And I want to put a drop right where the motor shaft comes out of the motor. So I'm going to see a little drop come out, just a tiny bit. There we go. And then I'm going to put that right on the shaft. Do the same thing for the other side. I'm going to have a little drop come out. You probably don't see it. And then I'm going to put it right on the shaft. And let capillary action pull it in. I can now seal this up. That's done. And just spin the motor a couple times, a few little bit. Alright, so that takes care of that. Now again, before I put this motor in, I want to lube up these hex openings for the dog bone. Remember when I was doing all the other lubricating on the trucks and stuff, I said that everything that moves or has a bearing surface or will get lubricated. Alright, so that's taken care of. Now we want to lubricate the ends of the dog bone that go into the worm gear. I'm going to stick those into the worm gear bell housing. Now, one thing I want to say here, this is not the way to put these dog bones in. It's much easier to have the worm gears out and the worm gear clip off and the worm gears out to do this than the way I'm doing it. The way I'm doing it, there's a possibility that you can break these things. So don't do it the way that I'm doing it. But I don't want to take these worm gear covers off. So I'm going to risk it for the biscuit. I've heard that before, and I'm like, I've never had a reason to use it. Okay, so, alright, so this is the front of the frame. So we got the front of the motor here, and I'm going to put the hex drive into there, and now I'm going to do my best to flex this hex drive back here, or the dog bone back here, and get it. It's really difficult to do, but to get it into, there we go. Okay, now I've got the motor mounts all screwy, and there we go. What was it? Oh, my scale rule fell on the floor. Now we just want to spin that, make sure everything's working well. Okay, now we can get the motor secured in. It'd be better if I had Japanese standard Phillips heads, but I don't, because these don't fully engage. There we go. Motor is now in. Okay. Next step, push this back. Next step is to get the DCC board ready. Should have cleaned all this up first, but let me just get this out of the way. I'll clean that up later. Alright, so the first thing I'm going to do is I got to drill these guide holes out with the correct size drill for a 080 tap. I don't know exactly what that is, but you can look that up. I think it's a 045 drill bit, but don't quote me on that. Just look it up. It's easy to find online. And I'm drilling them from the bottom because I made these posts on the top a little bit smaller than what I had before. So if I go from the top, it cracks them around there. I've cracked a couple coming from the bottom, but it's much easier to do it, or much safer to do it from the bottom. And what I do is I drill up to just the base of the top post, and then I clean it all out, and then I go back through. And that tends to keep that top part from cracking. So right now, see, I can see the drill bit inside of there. So now I'll pull it out, get all the crud off it, and I will go all the way through now. And I didn't crack it. Now you might think that I'm going to crack it when I do the threading, but I let the threads cut rather than push through. Okay, that one did not crack. I don't think you can see on film the drill bit cutting inside of there, but right there's the base of that top part. Okay, that one did not crack. And that one did not crack. Okay, now we're going to take a 080 tap and we're going to come in from the top. And I'm just going to let the tap cut. Go in, back out, go in, back out. Now the reason why I'm backing it out is because the material is packing on the inside. If I back it out, it clears out the packing. There's one. Now let's do the next one. Now by going back and forth so quickly like that, I was able to get it all cut in one try. See, where are we at? We're at about just a little past halfway on the download. Now I started that download before I started this, so and I took a little break between when I started the download and started this install. All right, one more. And there we go. Alright, that's all taken care of. Now I can install that over the motor. So make sure we go to the front. The red wire is the negative, so it goes to the back side. The black wire is positive, so it goes forward, and these will line up with the board. Let me clear this off. Move the frame forward. There we go. And we'll get this secured in place. There we go. Okay, get the screws. Whoop. Now I hold the bracket, the rubber bracket around the motor because I don't want it to torque sideways. I want it to stay nice and perpendicular. I have a tendency to put my tools down where I put my arm down, and I get a bunch of goo all over it from this rosin flux. There we go. So the board is in, the motor's secure, and everything's taken care of. Next thing we want to do is clean this up a little bit. Okay. Alright, about 3/4 of the way on the download. Alright. Get these iPhone speakers out. Now I want to show you something after I cut them. They're not all the same. They look the same, but they're not all the same. And I'll show you why in a second. Okay, so I've got enough room in between these posts for about a 2-inch long speaker canted a little sideways. So what I want to do is take this block. First of all, I want to cut off this bracket. Trim it. Alright, now I need each half to be 1 inch long. So this end of the speaker is flat, so I put that up against, or is perpendicular to the length. So I put that up against the block, hold it in place, take my ruler, stick it down on there, hold that in place, and just mark it at 1 inch. Okay, and do the same thing on the other one. Cut myself. Alright, now what I want to do is I want to cut it just outside the line, and we'll put this in the mill and cut it down to that 1 inch. I already have the mill set up from all the other ones to cut it at the 1 inch. So I just want to take this razor saw and I just want to cut through it. Now I said I wanted to show you something, and I will in just a second here. Let me just get these both cut off. There we go. There's one. There we go. So those pieces can be thrown away. Okay. Now, what I want to show you is, this is an iPhone 4S speaker also. It doesn't have any markings on it. Now, I should have shown you it on this previously. There's also one that looks like an iPhone 4S speaker that has markings on it, but I don't have it here. But anyway, these ones don't have the markings on it, like the serial number and all that kind of stuff. You'll notice on the inside there is no baffling at all. On these ones that have a marking on them, and I don't remember what it's called, what the marking is, but it says revision 2 on it. You can see inside of there there's some baffling. So all of these, I picked out all the ones that had the same markings on them, and they all have the baffling on the inside. So I had just enough for 6 units. So now what I'm going to do is I'm going to shut the camera off, set it over at the mill, and we'll get these things faced off. Now, as I mentioned before, I've got the bit set at the right height so that it'll cut these so that they'll be at 1 inch length each. So I'll just slide that in. And using that same surface that I used as on the straight edge to cut these, I'll put it on the parallel, press down on it, and then I'll squeeze this as much as I dare without cracking it. And the reason why I want to squeeze it hard is because there's not a lot of surface area that this vise is biting to. And if this mill bit gets a little anxious, it's going to grab and pull it. So I squeeze it as tight as I can without cracking it. So without cracking it. So now everything's set up. And I'll feed the bit slowly so it doesn't grab and tear the speaker out of its mooring. Now I'll come over here and I'll hold it. And that takes care of that one. We'll take it back over the bench and clean it. Put this one in place. Hold it down tight. Cinch the vise down around it. There we go. Do the same thing. And that's the last one, so I can raise this up. Alright, so that's what they look like all cut. We'll get it back over the bench. Let me turn the camera off, get it reset up, and we'll get these things glued together. Alright, so we're back here at the bench. And now I need to clean up all the sluff from around it from cutting. Because this baffle, on one side, it's sticky like a piece of tape. So they stick it to the inside. So I gotta just clean up the plastic that's stuck to it. You can peel that off. And it's okay if this foam stays out here. When you put these together, the foam just presses in. It doesn't like press out over the joint or anything like that. So I just want to make sure that there's nothing on these mating surfaces that's going to keep them from being tight against each other. Okay. Make sure I'm in the middle of the screen here. Alright. Man, I got garbage all over the place here. So the next thing we'll do, now you'll notice when I flip these against each other, one speaker will face one way, and the other speaker will face the other way, and they'll just be glued together just like that. Now the foam's going to push them apart, but once the CA's on there, it won't do that. So that's what's the next thing to do. I use the CA that you buy at the hobby stores. It has their name on it. I've found it to be the best CA out there. So I put a little bit on a piece of masking tape, that blue masking tape, and it stayed, there's enough surface tension to keep it bubbled up. And I am going to put a bead of CA all the way around a nice healthy bead all the way around this joint. Just like that. I'm going to set it down, and I'm going to line up these edges, this edge with the outside edge, just like that. And I'm just going to hold it there for about 30 seconds or so. This is a new bottle of CA, so it'll set up fairly quickly. And my download finished on GP35 the fifth one. So I'm just going to hold this here a little bit longer, and there's where some of the CA oozed out. There we go. And now what I'm going to do is I'm going to put a bead all the way around the joint. When I'm done with this, I'll show you what these sound like. I'll bring the camera over to the computer area and we'll start that one up that just finished. And there we go. Now I just gotta let that set for just a second while I get the decoder out. And what I'm gonna do, this is a V4. 5 of these have V4s, 1 of them has a V5. I thought the V5 was a V4, but it's a V5. I'm going to pull the decoder off the board, set it aside, and now I'm going to flip the board over. I'm going to face the motor and speaker leads towards me, and see, this is going to glue onto the board. Oop, nope, I face them away from me. This is going to glue onto the board basically just like that. What I have to be very conscientious of is to keep the speaker away from these mounting holes so that they don't interfere with the posts. So I can get some CA out here. And I'm going to, what the hell is that? I'm going to put some CA on here. Some CA on here. And now comes the trying to carefully line it up so that I don't screw everything up here. See, I already almost screwed it up. There we go. Now it's glued on, and now I'm going to take some CA. Now some of you might be cringing at this, going, well, what happens if the board, something happens to the board? Well, you're saying a really big prayer that nothing happens to the board. But I highly recommend that you test everything before you do something like this. And so far all these speakers work, or I mean all the speakers and all the decoders work. So right now I'm just putting a bead of glue around the contact points for the speaker so it holds in nice and firm. Now you could also do this with silicone sealer. Silicone sealer. Silicon is what they make microchips out of. Silicone is what they make fake boobs out of and tub and tile caulk. Alright, so that's taken care of. Now comes the time to wire up the speaker. So, I've got my wire from Loke Sound. I cut 2 pieces at 1 inch. And I cut 2 pieces at 1.8 inches. You could do 2 inches or you could do 1.5, but I found that the 1.8 works just fine for me. Alright, now strip these. Let me get my soldering iron turned on. So I strip 1 end short. That's the end that goes to the speaker. And I strip 1 end long. That's the end that goes to the decoder. One end short and one end long. Same for the short pieces. One end short, one end long. Alright, now I will flux these up and tin them. This stuff I got from Radio Shack a long time ago. It's so gooey, I need to get some new stuff. Got my soldering iron, got my solder. There's one. Soldering iron. I'm trying to move as fast as I can, guys, so that you don't get too bored with this. And there's two. There's three. There we go. Alright, now we need to solder it onto the speaker. So the long wires go furthest away from the connections, and the connections for the speakers are here and here. Speaker 1, speaker 2. So here and here. So what I gotta do is take the short end, get some flux out here, put a little bit on the pad, a little bit of solder, there's one, the short end, a little bit of flux on here, and on the pad. Put some solder. There we go. Now those are on good and tight. Now we'll do the short pieces of wire, again with the short end. I need a new solder sponge. There we go. And the last piece. And there we go. Now I need to join these wires together. The key to making sure everything works properly is to make sure you join the wires to the correct pad. So this is the outside, this is the inside, this is the outside, this is the inside. So I take an inside to an inside. If you don't hook these up right, your speakers aren't going to operate properly. And I'm going to twist those together. Flux them up and solder them. There we go. Now we're going to go outside to outside. Here, so we're going to twist those together. And keep these inside ones out of the way. Glue those up, put some solder on them, and that takes care of that. Okay, now move this stuff out of the way again. Got so much crap around here. Pull this over, and we can mount this up. So I need to go. What do I got here? Got a clogged hole. There we go. Okay, so we go negative to negative, positive to positive. Oh, before I do that, yeah, I got to do this. So this wire goes through here, speaker 1. This wire goes to speaker 1, and this wire goes to speaker 2, or vice versa. It doesn't matter. But all of my wires are done the same. Except this guy doesn't want to cooperate. Press those down in there. And bring these across. Press those down. Those down, bring that into there. Alright, buddy. You're the only one that didn't want to cooperate. So I'm going to have to hold you in place. Alright. Whoop. Quit dropping down. And you need to drop back down. Oh, there we go. Okay, we're going to glue those up. Get a good glob of solder on your soldering iron. There we go, fill that hole. Ooh, that's hot. Get some more solder. Fill that hole up. And the speakers are now soldered in. I'll cut the excess wire off of them. Wipe off the goo. There we go. Now we can get these wires organized underneath here. There we go. I just don't want them really pressing on each other. Now we go negative to negative, positive to positive. Pull those through. Set that in place. Whoop. What a mess. I hate working in messes. And I've got these long 080 screws. I ran out of the 1/4 inch screws. These will work for now, but I've got a whole bunch of 1/4 inch screws, 3 or 5/32 and 3/16 coming in. So when I get those in, I'll replace these. So right now we're just going to use these. These work and they don't interfere with anything, but they just don't look professional. So when the other ones come in, I will put them in. So we're going to get these all tied down. They don't need to be gorilla tight, they just need to be cinched. You can't really gorilla tighten them anyways because you'll strip out the threads. There we go. So now the board's in. So now what I do is I pull these wires down until just the wire, so the insulation's right at the bottom of the PC board and the wire's sticking out. Same thing with this one. There we go. Get those all gooed up. Alright, get some solder. Nice bead of solder. Fill those holes. There's that one. And there's that one. Now I'll come in and cut off the excess wire. Wipe off any excess goo that's on there. And the wires are now, you have a nice solid connection for the motor wires and the speaker wires. Now what I need to do is tuck these wires, motor wires, up underneath the motor area. There's that one. Take the black wire, get it stuffed up underneath there. There we go. Now when you slip the shell over it, nothing will interfere with the side of the shell. So that takes care of that. Next up are these truck leads. I don't know why these wires pulled in, but we need to take them out. I need to strip off some of the shielding here. These things are extra long anyway. There's that one. This one I just need to pull the wire out a little bit more. There's that one. That one's good. And this one, a little bit more on that one also. There we go. Alright. Excuse me. Now we will glue up the ends of the wires. Hope I'm on camera. Yeah, that's good. I need to pay attention to what the camera's showing. Glue up the landings. Now these are going to look like there's a lot of wire, extra wire, and that's on purpose. I used to subscribe to minimalizing the wires. But then it came to a point, if there's ever maintenance, it's really hard. You know, if you've got to desolder something or cut something, you've got to redo all the wiring. So this way, you have plenty of extra wire to play with. So we're going to solder that in place. There's that one. There's that one. Yeah, that's solid. Okay. Spin this around. Some more solder out here. There's that one. And there's that one. Alright, so the truck wires are soldered in. Now when I put the shell on, these will tuck in around like that. Well, actually this is the front, so it's got to bend down, and then I'll tuck it in and stuff like that. So right now they just look like big old loopies hanging out. Okay, so that's taken care of. Let's move right along. Next order of business is keep alive. So make sure you understand something here. The V4s do not solder, or I'm sorry, the V5s do not solder to the same pads as the V4s. So look at your instructions and make sure you're soldering to the correct pads. Alright, so let's pull this wire out. Hold the wires tightly at this end and just stretch them out. There we go. Okay, so now we take our decoder, and this is a V4 instructions. And even though I've done enough of these to know which pads I go to, I still look at the instructions to make sure I'm putting them on the right pad, because I have a habit of thinking I know what I'm doing and doing just the opposite, not knowing what I'm doing. So I'm going to flip this upside down. I'm going to orient my instructions the same way that my decoder is, and black wire goes to this pad, white wire goes to that pad. So you go black wire, skip a pad, white wire. The red wire goes to the pad directly above on the opposite side where the black wire is. So go this way. I'm going to pull out the black wire from this mess of wires. Alright, we're going to get some goo on that one, a little bit of goo on the pad, a tiny bit of solder. Yeah, the solder I need solder that stands up. There we go. Alright, a little tiny bit of solder there, and is that on? Yeah, that's on camera there. So we're going to take that, hold it right there, and that's soldered in place. Alright, now we need the white wire. That is going to go to this pad, so let me get some more goo. Get my solder on there. There we go. I'll hold that white wire right there. The solder side down. And there we go. Now, the red wire goes directly over where the black wire is. So that is going to go to, I don't know if you can see it here, but that pad. There's the black wire. So it's going to go to that pad right there. We're just about done with this install. So put some goo on there. Put some goo on there. Give me just a small amount of solder right there. Red wire. Soldered on. So that takes care of the keep alive. Now we just take the decoder and we will snap it into place. Just like that. Next, the keep alive will be sitting right into that where I cut the notch out with the ball end mill. So I need to glue that in place. Turn off my soldering iron. Glue that in place with some silicone sealer. Get a little blob out there. Put some there. Put some there. Make sure there's enough on there so it holds in place good. Alright, clean off my screwdriver. I use a screwdriver for all kinds of stuff. Alright, then we're going to set this right down in there and make sure it's nice and straight up. And that takes care of the install. Now I have to just go program it. And this is going to be a CNEI unit, so it's going to have a Nathan air horn on it. So I got to program that in. I already did one, so I'll just copy the file, change the road number. So let me go do that, and then I'll set the camera up over at the computer, and we'll give it a good listen. Okay, so I have all of the 6 GP35s with decoders in them and all programmed. One of them is being reprogrammed right now because I accidentally put the road number as 650 in it instead of 605, so there's 2 650s in this consist, so I had to reprogram the lead unit that would go here. So anyway, what I got to do is I'll just give you a startup. I've knocked the volume down on the prime mover by 50%. So on the V4s, the max is 128, so I've knocked it down to 64. So I'm going to give it a startup, program it in. I already got it into the power cab, so just hit number 8. And then this one are all of these CNEI, ex-CNEI units have K3LA horns in them. And all of the TNP and Missouri Pacifics have the RS3L horn in them. So let me get this started up. Now these all start moving really smoothly at speed step 2. But I'm going to try it at speed step 1. Let's see what speed step 1 does. There's 1. See what it does. I don't have any momentum built into these things. So that's 1. Let's go up to 2. There's 2. They all seem to move really smooth at 2. Now what's really interesting, I was just running this before I turned the camera on. If I run this like really fast, like let's say speed step 10, and then I shut it down, if I don't let the motor sound come all the way back down to idle, and I change directions to come back and I ramp the motor up again, the sounds get mixed and it gets real staticky. So I have to let the sound go all the way back down to idle before notching up again. But that's okay. I won't be doing much of that anyways. And if you're switching, it comes back down pretty fast anyway. So there's speed step 2 again, coming in. And that's pretty much it. Not much more going on other than that. So I won't bore you anymore with this. Let me shut it down. And so that takes care of the sound install, the motor install, the decoders, you know, getting the sound set up and all that stuff. Alright, so as I just said, that takes care of getting the motor and the drives, the DCC boards, speakers, and the power packs or keep alives all set up in the frames. So all of them run. They all are programmed pretty much the same except for the road number. I did set the sound speed slightly different on each of them so that hopefully they won't sync up and they'll have just a little bit off so they're not, you know, sounding like one big motor. They sound like individual motors when running together. So all I have to do is wait for number 605 to finish programming and this portion will be done. Next up is we'll be moving on to getting the sill units done. So actually the modeling gets started now. And I'm hoping it goes pretty quickly. I don't have to wait for anything. Everything that's going on these is all KATO parts. The only thing that, actually everything is going on to them. So I'll be using the KATO, well anyway, I'll go over all that in the start of the next video. So I hope you enjoyed that. Again, and I really appreciate you hanging on and watching. If you watched the whole installation part of it, I know it was kind of long, but maybe you saw something that you can use. Maybe you want to do the same thing. If you do, let me know and I'll put the parts up for sale on my Shapeways page and such. So anyway, thank you very much for watching, and I hope you'll come back again for the next installment.